welcome to my channel. Today I will be explaining some basic concepts that you should know in Python if you really want to code in Python. And so we'll just introduce basic concepts now. Mostly I'll be talking about data types and um, subsequently move on from data types to allow you practice with some exercises and show you how to convert from the different data types one to another. I'll show you basic on expressions such as arithmetic, and then I will explain what variables are, and then I will end with coding style tips. Again, this is targeted for beginners to Python, so if you're just new to Python, this is a perfect video for you. And so before going into coding, which I already have here on the script so that doesn't waste your time, I don't waste your time, I would first of all summarize what these data types are. I'll try to explain them as much as possible to simplest form, and then we'll go into saying how to check the data types and how to convert them. And so these are the basic way the data is expressed, or these are the basic types of data if you want to speak that way. In Python, we have integers, which are basically whole numbers. We have decimal numbers, which are the floats, calling them floats, or numbers with decimals or fractions. And then we have strings, which are alphabets, so text. So if you see hello, for example, this is alphabet, these are strings. And then we have booleans, which could be true or false. Think of this as logic, okay? And so let's start with the first one. Let's start with the integers. And so let's make this markdown. So that's just what I did here to explain this content. So if I knew this, I'm using Jupyter Notebooks here. I'm using Jupyter Labs, and it's part of the Contour. Again, if you want to learn how to set up an environment, which I believe all of you already have at this point, but if you haven't, just comment help below, and I will guide you how to set up a code editor such as this. Okay, and so as I said earlier, integers, they are basically whole numbers, okay? And so for example, if you have something like, say, let me split that cell, and I define a variable and I say 5 is equals to 5. So integer example equals to 5, or int example equals to 5. If I run this now, this is passed into this, and this is now called variable. And if I want to check what that is, I could use the print. So I just say print, and then I print what I passed into there, and then I get 5. Okay, and if I want to check the type of this, I just have to use the type. So I just have to request for the type of this particular variable, and it should tell me that it's of class int, because we are integers, because this is a whole number, there's no decimal. Okay, so if we print that, then it will tell us that, oh, it's of type. So that's how to check type of numbers, type of variables, basically type of data in Python. Just use type, and then that will tell you what it is. So these are integers, basically tell me this is a whole number. Okay, and so in the next one, let's go to floats, which are decimals. Think of this as fractions. So again, let's render it so that it looks beautiful. We're going to the next section, and again, to make this look smaller, what you have to do is add a pound here. And so if you do that, it looks smaller, and if I add another pound, for example, it even gets smaller. Okay, and so float are numbers that have decimals. So there's this dot here, which makes this a float. If I remove the dot, if I just have only that, it's now an integer. If I introduce that back, it's now a float. And so again, we could do the same stuff. Let's just run this. And so it's same as what I did earlier, but now I pass this into float example, and I print the value of that float, and it tells me it's 3, which is what I gave, which is correct. And then ask for the type of the float, which is basically your type, and then you pass in your parentheses and pass in whatever data or variable or data you want to check, and it's telling me that this is a float because it's a decimal. Okay, let's go to the next one, which are strings. And strings, think of them as text. It's an alphabet. So let's render this again. Let's make it look nice. So just go to markdown there, and let's reduce that to look smaller, and that's text. And so this is an example, Hello Scientistica, which is just the name of this YouTube channel. And if I could split that and run this, then that gets passed into this, such that if I copy that and I just did bb and then I was able to create a new cell below, I paste this. If I run this, it should tell me that this is the content of it, because that's what we passed into that variable, and that's it. And we could as well use print statement to see, rather than just copying it and pasting it this way. You could also do print, and this is a string, and then this is the variable. And if I run this, it will tell me that the string example is the value of the string example, which is this stuff. Okay, and then we'll also check the type of the string example, and it should tell us that it's a string. Okay, so str is string. Remember, integer, float is float, integer is int. Okay, so let's go to the next one, which is boolean. So again, I will split that and render this up. Again, this code will be available on my GitHub, which the link to the code could be found in the description of this video below, so you don't have to memorize anything at this point or try to stress yourself too much. Okay, just try to understand what I'm saying. Okay, so boolean could be true or false, for example, and so on. Let's try to do that here by doing passing true to a boolean here. If I split that here, and always the first letter is a capital letter, so if it's the first one would be capital F. And again, you could just copy this and paste, and you tell us it's true. But if you want to be more Pythonic like me, and you could put in a long English, such as print a boolean example, and then pass in the value of the boolean example, and it should tell us this. And again, if you look for the type, it should tell us that it is a bool, which is a boolean. Okay. And so at this point, let's stop for a while and take a test or an exercise, just to make sure that you're following. I will do this together with you, by the way. So the exercise 1 is for you to create your own variable. So you just have to do something like this. Again, I'm doing this for you. For this first one, just create your example and then try to print the value and also check the type. And your variable should be integer, float, strings, and boolean, which is basically what we've been doing above here. So you could pause the video, scroll backward and watch that and try to do it. So for example, you could say variable int is equal to 8, which is 89 or whatever. So that's the variable. And if you check the type of that, it should tell us that that's an int. And you could do whatever the rest of them, the float, the string, and the boolean, just that way. And if you want to test yourself further, you could go through this, but it's not important. And so the next step is for you to be able to, one thing is to know which data type you have at your hands, which could be given to you, or it could be maybe from your calculation it moved from one to another, but maybe you want to use it and the particular function is expecting it to be in a different form. For example, you have floats and it's expecting an integer. For example, you want to loop, the index needs to be integer. So if you have a float in a list, then you want to pick each of them, then it becomes tricky. So you should be able to know how to convert from one data type to the next, essentially. And so I will show you how to do that. And so let's render this again to make it look nice, and I will make this smaller to be smaller than the heading. And so let's convert integers to float, for example. So I define a number. The number is 7. Again, we check this type. It's going to tell you that it's an integer, which you have done in the previous exercise. And then we want to get this number as a float. And so what you have to do is just call in this float. So let's split that so that we'll go step by step. If you do that here, and if you check this, if you doubt stuff like me, if you do a type of number, it should tell you that it's an integer, okay, which is true. Now let's convert this number to a float, and so let's split that there again. By using this method float, it should convert this number to a float, and we're storing into a new variable and number. We're calling this number as float. And so if you check the type of this, for example, as we are doing it, then it should be we just check the values here, which I've written it neatly here. So we check what is the value of number was 7, and it shows us 7. And as float, which is this one, to see what the value looks like now, we passing that into a print statement here, and then we'll see that it's a point. So we basically added a 0.0. So their magnitude is the same, but the expression is different. This one is like 7.0, this one is 7. Okay, so we've successfully converted this to this, and if we check the type of this number as float, it should tell us that this is a float because we use a float there. So if you do type of that guy, we should get that this is a float. Does that make sense? Yes, that makes sense. Okay, so let's go to the next one. So suppose you have a decimal and you want to convert that decimal now back to an integer, which is basically a whole number. What you have to do is to, let's render that to look nice. So we have, for example, 9.8, which is the value of gravity, and this is a decimal. If you want to convert it, you just have to use an int and pass in this into it. Again, when it's, I don't want to start taking it to an advanced level, but when this is more than a single value, say suppose you have 9.8, 9.3 or whatever, once it's more than one number, then this int wouldn't work. So you have to start using other libraries such as NumPy. So you could do NumPy.unassigned integer 8, and then it will convert all of them to integers. But now this, for single values, this will work perfectly. So basically we converted this from 9.8 to integer, and it's always going to just cut off the first one. It's not going to approximate anything for you. It's just cut off the whole number part of it, and that's what you get. Okay, so it's good to have to know there. So 9.8 is not turning to 10, but it's turning to 9, which is basically this first number here. And then next, let's look at rounding a float to the nearest whole number, which in mathematics is very, very important. And so, for example, you have this decimal number here, which is 9.8, and you want to round it, then you have to use this round function. So, for example, here it has one decimal place, and it's 8. So you could just do it to just round. By default, it has a comma 0. So suppose we have even a complicated number like 9.867 whatever, and you want to make it a whole number. If you just do round, it will make it a whole number. But if you want to go to 2 decimal places, you just pass into 2. For example, in this case, it will fail. But you can make it 0, and it will give you the same value. But notice that it's going to be a float. Compared to, like, if you leave it this way, then it's going to give an integer. Okay, you have to know that. So that's how to convert from one to another. In this case, we just did the basic ones, moving from float to integers and integers back to float. In the exercise here, you create a variable with decimal value and convert it to an integer and then back to a float and print the result, which is basically what we did here. So if that was not clear, please stop the video, watch it again, and practice with this exercise. These are designed to help you improve your coding. The next one, let's do basic on arithmetics in Python. Again, this could be used for data science, and so if you are interested in the aspect, in fact, if you're not even interested in data science, you have to know this basic expression at least. And so let's start with the first one, which is addition. And so to do addition, I would do that one, and then I would do, for example, add 5 plus 5. So this is the result. And then we could print 5 plus 5, which is a string, is equals to the result here. So if you do that, we should see 8. Yeah, which is correct. You could also do subtraction, for example. So let's play that. Let's render this as markdown again. So just click here, convert that to markdown, and this is subtraction. So if you have 10 minus 4, we pass in the result to subtract result, and if you print what is 10 minus 4, this should give us 6, and that's correct. We could do multiplication. Notice that this is a minus, the other one was plus. Multiplication is an asterisk, so don't start looking for an x. Don't do 7xy as my brother would do. Okay, so let's render this again to make it nice. Let's even add 4, and let's see how this was 3, this is 4 pounds, and you see that this is smaller than that. Okay, so you have that flexibility of reducing the font by increasing the number of pounds. So 7 times 6 is how you write it, and this should give you some nice value, just the 42. You could also do division by just doing /, which I know all of you already know it. And if you render there, then this divided by this will give us 8, and that's 8 point there. And you could also convert this to integer by just putting an int there, and if you do that, then you should just give 8 rather than 8.0. Okay, so there's an exercise. You have to create your own expression using all the 4 operations: plus, minus, times, division. Try different combination and print your results, which is basically what you've done here again. But now try to form your own expression. You could go back to your mathematics notebooks and try to type some of the equations your teacher has been writing on the board and see how it turns out. Okay, next let's go to variables, which we've already I've already commented it later on it, but I will do more now here. So variable basically stores the value of your data. So for example, if I have this divided by this and you intend to use it later, for example, as say this was your circumference and this was your diameter, that's equivalent of pi. So you could store it in pi, which is an alphabet. In this case, they are alphabets pi I, but it has a value that corresponds to the answer of this. So that's a variable. So it allows you to store. So you could use a name that's descriptive to store your expression and use it in your mathematics equations, so that life is more easier and it's easier to understand for other people reading your code. Okay, and so pi is equal to that, and you could say our radius is equal to 2.5 meters, for example. So we have radius and pi. So instead of typing this number over and over again, we just say area of a cycle is pi r square, and this is pi times r, and this is how to do raised to power. So it's pi r square. So star is raised to power. Okay, and then we could split this off here, for example, and then let's split that, and then let's render this back here. Okay, and if you run that, okay, we did not define this. So some of the errors you get. So numpy is not defined because we did not run this there. So you run that and then run this again, and then that goes away. And we could print the result of the radius and the area here, which is already showing on the screen here. Okay. And so let's change the value of radius, for example, and see how this affects the calculation. So initially we're using 2.5, now we're going to use a 4 and repeat the same stuff again, and we'll see that our answers will be different. So basically it's just a way of telling you that you could override on your variables. Okay, so they're not immutable. So this is now the value, and if you run this and if you compare these two answers, they are not the same. So here's an exercise for you. Exercise to write a script to calculate the volume of a cylinder. You know the formula already, and use the formula volume is equals to pi r squared times h, basically. So just code these equations and print out the volume. With that said, now let me just tell you stuff that you should avoid. You shouldn't be using variables that are too long to type. So for example, pi is short, for example, but if you have something that says cycle area, this is descriptive, so to say, but sometimes circumference, instead of writing a full circumference, you could just say second. That's shorter and it's easier to like type it, you know. So don't like write very long words. Calculating circumference of a cycle is equal to blah blah blah. That's too long. Try to use short and descriptive words to store your variables. Basically, that's what I want to comment on. You get to see how I name my variable over time, and you should be able to learn from that. Please subscribe if you haven't subscribed yet. And then the last part is readability. So you want to write your code so that it's able to be readable. Someone picking up your code could easily see, oh, this is what person is doing here. And I think the video is getting long. At this point, I will stop it here. I don't want to go above 20 minutes. And so I will explain this other part in the next video. Thanks for watching, and please subscribe and leave a comment below, like it so that it will reach other people that are interested in this kind of content. Bye.